All right, so for these, we're doing new graphs. And again, they're going to be very similar to when we were graphing x squared. Big thing going back to doing those. Again, if we were graphing x minus 1 squared plus 3, you've got to remember the inside number is your left to right movement in the opposite direction. Your outside number is your vertical movement. That one you go in the normal direction. So inside is left and right, outside is up and down. So it's a good review, kind of going back and picking up on those. The new graphs we're going to do, because our old graphs were x squared, which again was like this. We had absolute value of x, which was the V-shaped graph. Those were the two. Those are the old graphs that we were doing. The new graphs that we're going to look at are x to the third and for x to the third. Again, we're not going to plot the points and go back and do all that. We're just going to say here's what the basic shape of it look like. So for x to the third, it's the basic shape of it. If we don't do anything to it at all, it looks like x squared because it curves, it comes down. But instead of going back up to be positive, x to the third, it's still going to continue on to be negative. And then x to the fourth is a lot like x squared. The big difference is with x to the fourth. So with x to the fourth, it looks a lot like x squared. The big difference is that when it comes down, it stays flat on the bottom for a long time and then goes back up. So it's a x squared graph, but it just flattens out a whole lot here at the bottom. So if you had x squared would look more like this. X to the fourth is going to be really flat on the bottom, where it's kind of sits on the bottom for a long time. Okay, and one more that may sneak in there just a little bit is the square root of x. And square root of x is one. It's going to start at 0, and it's going to curve and go up, and then it flattens out, so it looks something like that. So it's only half a graph, if you can kind of think about it that way. Everything else goes all the way left and right on those. Square root of x is one where this one, your domain, goes from 0 to infinity. Okay. And I don't think a lot of these questions, I don't think they will ask for domain and range. The good thing is if they do on x to the third, domain is negative infinity to infinity. The range is also negative infinity to infinity. So I don't think they'll ever ask that on x to the third. X to the fourth is a lot like these two, that your domain would be from negative infinity to infinity. The range, because again, it starts at 0 and then goes up, would be 0 to infinity. So that's where all of these, x squared, absolute value of x, x to the fourth, they all have the same domain and range in the basics when you start off with it there. Okay. And because square root starts at 0, 0, we start both of these at 0, 0 for your domain and range. Okay, so what we're going to do, we're just going to have some problems on here where all we're going to do is I'm going to ask you to graph one of these three kinds of graphs, and still may get some x squared mixed in with it too, so that may still pop in there. It's going to give you a graph, and you just got to move it up, down, left, right. So nothing new, nothing weird, nothing different from what we've done in the past. It's just different shaped graphs as you go through those. And most of these, probably a lot of these will be some multiple choice, especially like x to the fourth would definitely be a multiple choice type question. Because I don't know that there's an x to the fourth button when we're doing Math Excel. So that definitely would be that way. Okay, so we're going to do x minus 2 to the third plus 3. Okay, and again, the big thing on this one is it doesn't matter whether this is x squared or x to the third or x to the fourth or even x to the fifth or x to the sixth. It should be pretty much that for this one, you know that for this part of it, you're going to move on the inside number. We're going to move it left and right, opposite direction. -2 is to the left. We're going to go 2 spaces opposite way to the right. And then 3 up. Okay, so instead of being at 0, 0, again, 2 spaces to the right. And then 3 spaces up would put us here. And then we just basically from there, again, it's just making sure you got the right shape of it. It should just be that kind of S-shaped curve. You know, it's really an S shape. It's more of just like a lazy line almost, where it decides in the middle. Instead of just going straight, it's going to bend for a little bit. Oh, now in some of these, it may even ask for like the end behavior. So if you're doing one of these and it's a positive x to the third, that, you know, in this case, because it's positive x third, that's where we go back to our chart. You should know that the right side would be up and then the left side would be down. So they may even bring some of that back in there first to just having you do some of the end behavior on those. Oh, so it's a positive x to the third. So if that's the case, then your left side of the graph has to go down, like we've got here. Right side has to go up. I think that was 2 or 3 days ago. I don't remember exactly. All right, do a couple more graphs just to make sure everybody's okay. And again, don't have to get super detailed on these. And again, for that, same thing in Math Excel, if you did this one, if you click on the shape here, it should kind of put that shape in there for you. And kind of like we did before, as long as this number in front is just x like this one, if it's always just x to a power, you can kind of do the shortcut of just going up 1 and over 1 to get your next point that you would have to drop in there. But I think a lot of these will wind up being multiple choice.
How did you know it was positive again?
If you just look at the sign in front of the x here. So if it would have been negative, it would have been a negative x to the third. Okay. And we'll show you one in a minute where you can actually see that part stuff. All right, so let's do. We'll do x plus 4 to the fourth minus 2. Okay, so we have 2 numbers. Again, figure out which way we're going to move this graph first. Number on the inside, again, it's opposites, left and right. So we're positive 4 usually to the right. That means we're going to go 4 to the left. The negative on the outside, that's our up or down. In that case, that means it's going to be 2 down. Okay, so 4 left, 2 down. That means should have a lot of room this way. Okay, so if you got your XY axis, we'll need more room down here in the bottom because that's where we'll kind of stick around over there. So 4 left, 2 down would be there. And again, if it was x squared, it would look more like this. If it's x to the 4th, it should come in and get kind of flat for a little bit. And then turn and go up like that. All right, so for number 3, we'll do square root of x minus 2. Okay, there's only one number this time. It's on the inside. So again, it's opposite direction. Seems like it's to the left. Actually, we're going to go the opposite to the right side on this one. There's not a number back here, so there's no up or down. So this one, we're just going to wind up moving this one left and right. Okay, so again, instead of going to 0, 0, just go 2 spaces to the right side. And then just kind of give it a quick sketch so it looks something like that. Okay, and then the last of the graphs. We'll do negative x minus 1 to the 3rd minus 3. Okay. Again, here's one we'll do the end behavior on this one just a little bit. Now, they would not ask for one like this. They won't ask for end behavior. It have to be something that's either x to the 3rd or x to the 4th. So if you look at your x's, it's negative x to an odd power. So again, you got a negative out front, so that's the negative. We've got x, and it's an odd power. So if that's the case, you should know that the left side is going to be up, and then the right side would be down. Okay, so the 1 on the inside, again, opposite way, so that's 1. Seems like to the left, actually it's going to be 1 to the right side. 3 that's here on the outside, so we'll make it 3 down. Okay, so again, make sure we got the movement correct first. So 1 right, 3 down would put us here. And again, x to the 3rd normally would go like this, but because of the negative in front, Sam, it's got to go backwards. So now the left side is up, and the right side would be down. Okay. And if they ask you to, some of these I may even just not even give you a graph, I may just ask you to describe it. Just remember that negative that's in front, that just means that's a reflection. over the x-axis. And then the last couple things we got. One last thing. They're going to ask you about different, going to give you different functions, and they're going to ask you if these functions are even or odd or neither. And this is like really, 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 really like easy stuff on that part. Everybody get on the graph? Okay, the last thing we're going to do is even, odd, or neither functions. Again, this is really straightforward, really easy when we come off these parts. And there's really just about one or two little things you got to watch out for tricks. Other than that, everything else is really straightforward. Even functions, believe it or not, have all even exponents. Okay. And if a function has all even exponents of its even functions, it has y-axis symmetry. Okay. Odd functions sounds like what you think it would sound like. They have all odd exponents. Okay, and the symmetry on this one's a little. It's not as easy to say as y-axis symmetry. On this one, they say it has symmetry with respect to the origin. Okay, and again, you can. I guess you could say origin symmetry. It's not really the way they say it. It's a little different how it's set up. But basically, you've got either y-axis or origin when it comes off these two. That's the only two that we're really looking at for this part of it. And then the neither part. Has odd and even exponents. So if it's got a mix of even exponents and odd exponents, then they say it's going to be a neither. So even functions have all even exponents, odd functions, all odd exponents. And if it's neither, it's got a mix of both of those. And again, everything for the most part is pretty straightforward. There's one or two little things you got to watch out for. It's kind of sneaky. And if you got those one or two little sneaky things that's there, then everything else is really straightforward, really easy when it comes off of it. Okay, so what I'm going to do, just give you some examples here. Says tell if the function is even, odd, or neither, and then if it has symmetry, tell what symmetry it has. Okay, so again, first thing is even, odd, or neither, and then once we got that part of it, then we're going to say if it's got symmetry or not, and then if it does, we'll say what it is. If it doesn't, we don't say anything. Don't worry about it at all. And again, this is one of those where you definitely don't have to overthink this one. If you overthink it, you can definitely mess this one up because it's easier than what you think it is. Again, just got to watch for one or two little things. Okay, so we got 3x to the fourth and 10x squared. All you're doing is, and you don't even worry about the numbers. You're worried about just the exponents. X to the fourth, x to the second. They're both even. So tell if it's even, odd, or neither, then it's even. Okay, and if it's even, back up here we said it's going to have y-axis symmetry. So if it says name the type of symmetry it has, we would just say y-axis. Okay, and somebody's thinking, well, that's pretty easy. Yeah, and for these, it should be that easy. Just look at the powers, look at your exponents, and that's all you got to worry about. Okay, so for the next one, we've got negative 7x to the fifth plus 3x to the third plus 2x. Okay, now here's the part where you got to be just a little bit careful on these. You've got x to the fifth, which is odd. You've got x to the third, which is odd. What power does that x have on it?
One.
Got the understood one, right? So that's one you got to kind of be careful on that one because sometimes that'll sneak by. That's to the first power, so that's also odd. So it would be odd. So if they ask you what kind of symmetry does it have, it would have origin symmetry or symmetry with respect to origin. And they should just give you that option of either y-axis. It should be like a drop-down menu of one of those two things. Okay, so that's the only thing. That's one of the sneaky things you got to watch out for. If there's not a power there, you just got to know that in that case it would be the first power. All right, two more, then we're done. So go 6x squared plus 3x minus 1. Yeah, so we got x squared. We just said this one would be technically x to the first power. So since that one's even, that one's odd. We don't have to worry about checking the one that's there. It's just going to be neither because we got x to the second, x to the first. That means it's going to be neither. All right, and then the last one. We got 4x to the third plus 15. Okay, because most time people look at this when they go, oh, I got x to the third. There's no other x's, so it's going to be odd. Well, here's the trick question on that one. If you've got a constant like this where you've got the 15, if that's just a constant where that there's no x's with it, that means that that basically is x to the 0 power. So technically on this one, and this is where again, just that little detail you got to be careful of. When you've got 15 there, it's technically 15 and it's x to the 0 power. So really it's 4x to the third plus 15x to the 0. You've got one that's odd, one that's even. So that one also would be neither. Okay, so back up here, technically this one would have been 1x to the 0 power. So this one also would have a 0 power there, but we didn't have to worry about it because we already had the even odd here for this one. Okay, so if you've got a constant, just remember that when you see that one, you still got to think that it's x to the 0 power. And then that way you can kind of check the exponents from there. That's the only thing you got to be careful of. Just be, it's a little bit tricky as you go through this.